As early as 1934, Winston Churchill had warned the government that Britain must build a new air force. As Churchill had predicted, the German Air Force was close to achieving total superiority in design and quantity of aircraft. But the British aircraft industry was already responding to the challenge. Barnes-Wallis had spent much of his early career designing and building airships. The pinnacle of his achievement in this field was the R100.
Built by Vickers and flew to Canada and back in 1929. Vickers had been building airships since 1911, and the R100 was probably the most successful airship ever built in Britain.
The R100 first flew in December 1929. It was transferred from its factory at Howden in Yorkshire to Cardington. The following year, the great airship made a record flight to Montreal in Canada. It stayed in the air for 78 hours on the way out and 58 hours on the way home. It seemed that the R100 had made airships a commercial reality. But the crash of the infamous government-built R101 in 1930 finally put paid to the whole airship scene. But by this time, Wallis had already taken his talent to Vickers Aviation. In 1930, he transferred to Weybridge as chief designer structures. His previous years of research into the use of light alloys and his lattice framework for the R100 were good basics for working on aircraft. His first aircraft project using his geodetic method was a long-range, single-engine, general-purpose bomber. The Air Ministry had already placed orders for a biplane, but Wallis persevered with one of the monoplane designs as a Vickers private venture using that pioneering geodetic technique.
I drew it with the knowledge of how would I go about to make this. And I think it was very important because so many draftsmen and designers in those days could design something very fancy that would do a job, but when it got down in the shops, chaps came back and said, here, look, I can't make this. How do you expect me to get in here? How do you expect me to get my fingers in to do this bolt up? So I think my shop's benefit really paid off a treat.
A geodetic line is the shortest route between 2 points on a curved surface. The principle is well known to navigators plotting courses round the world. Geodetic structures accept stress and loads more easily and more quickly than normal airframes with their greater preponderance of metal sections. So geodetics give you greater strength without increasing the weight, something that designers have been striving for since the dawn of aviation 30 years previously. Wallis's monoplane flew for the first time in June 1935. It outperformed the Air Ministry's biplane in all respects. Within weeks, the biplane order was cancelled and replaced with one for the monoplane, now called the Wellesley. It entered service with the RAF in 1937. But despite its advanced airframe structure, it was too slow and too lightly armed to cope with new German fighters. Instead, most of the Wellesleys were deployed to the Middle East. There, its long range was invaluable, and there was only the Italian Air Force to contend with. However, in 1938, the RAF showed the great potential of long-range flights when two Wellesleys set up a record flying from Ismailia in Egypt to Darwin in Australia, at distance of more than 7,000 miles non-stop. Perhaps the importance of the flight was lost in the euphoria following the Munich disagreement, but within 1 year, the knowledge gained was invaluable in long-range bombing missions. In 1932, the Air Ministry had issued a new specification for a heavy bomber. Its weight was restricted by the terms of the Geneva Disarmament Conference. But with Germany and Italy saber-rattling across the Channel, the specification was constantly revised to take in heavier and heavier designs. Wallace's geodetic design had proved that powerful engines could be added to a light airframe without restricting the load-carrying potential. The prototype Wellington flew for the first time on the 15th of June 1936. That was the start of an intensive flight trials program. The aircraft demonstrated a top speed of 245 miles an hour, a range of more than 3,000 miles, and a maximum bomb load of 4,500 pounds.
The first test flight of the B932 was done at Eastleigh, because it was considered that the runway at Brooklands wasn't really big enough to cope with it. It was done by Mutt Summers, who was the chief test pilot at the time, who incidentally also did the first flight on the Spitfire. One of the great test pilots, old Mutt. You could take his judgment for what was right as being right. And when he emerged from this first flight on the B932, I've heard him use the same phrase on other aeroplanes, and I gather he used it on this one. He said, "Take it away and don't do anything to it, it's all right."
Later that month, the prototype was displayed at the Hendon Air Show.
I'd come up from Devon just to see the new aircraft, and there was this lovely, silver, shining, large aircraft, which was so utterly new. I've been studying aircraft for a long time, and I knew the new aircraft were coming, and I came up there to see these great breakthroughs in design, which we knew would be part of the enlarged Royal Air Force. And the Wellington was quite outstanding. It was so different. It was silver. I think that in itself was a mark that put it aside from the other aircraft. But I remember it standing in the park there, and to me, it seemed so desirable. It was something that I would have thought anybody would want to fly. I thought it was then going to be the backbone of the Royal Air Force.
The first operational Wellington was delivered to No. 99 Squadron at Mildenhall in October 1938. By September 1939, the 8 squadrons of No. 3 Group Bomber Command were equipped with Wellington Mark 1s and 1As, and they were ready for war. On the 1st of September 1939, Germany invaded Poland. At the spearhead of the invasion was the Luftwaffe with 1,600 aircraft. Meanwhile, the Air Ministry was concerned about speed of production.
But it was obvious that production rates were going to exceed what we could hopefully produce in the Weybridge factory, and so 2 shadow factories were set up, one at Chester, which was essentially just an assembly plant, and another one at Blackpool, which did quite a bit of manufacturing and assembly. And both of these plants were originally manned by people who were transferred from Weybridge, from the drawing office, from the workshops, from the tool design and tool places, in order to get the production going. Production at peak in the 3 factories rose to something like 40 aeroplanes a week. In fact, in one single factory, the greatest number produced in 1 week was 25.
Then comes the big moment. The engineer climbs into the cabin, and the engines are started up for the first time. Everything has received its final test and okay, and the bomber is ready for the takeoff. It's full daylight and 10 minutes to 9 in the morning. 10 minutes short of an exact 24-hour day that the finished bomber is rolled out onto the tarmac adjoining the factory. The record is going to be really shattered, and no mistake. Here it comes, and the bomber is airborne. The record? Yes, they broke it, those workers. They said they'd build a bomber in their spare time in 30 hours. Its wheels lifted from the ground in exactly 24 hours and 48 minutes.
Because of its portly, well-fed appearance, the crews affectionately nicknamed it the Wimpy, after J. Wellington Wimpy, the hamburger-munching cartoon character portrayed in the Popeye comic strip of the time.
Right, starter up. Connect port. Connect port, Pep. Contact port.
From the 4th of September, the bombers began dropping leaflets over Germany, appealing to the German population to give up their warlike ambitions before it was too late. But the value of these raids was questionable, to say the least. More importantly, Wellington's attacked German naval targets. Losses mounted from the very first raid. The main problem seemed to be a lack of defensive armament to cope with enemy fighters. Wellingtons had the standard front and tail turrets, and on the Mark I's, an unpopular retractable under turret, but they were of old design and they couldn't traverse through 180 degrees. It was not until the Mark II that new Fraser-Nash turrets were added, together with beam guns that replaced the under turret. Another problem was that there was no agreed formation for the aircraft. Individual pilots could choose where to fly.
In those days, this was before we really got down to the very definite bomber stream and so on. There was a lot of individual flying going on by the particular crews. Like, I always liked to fly as high as possible, way above the other aircraft. And I invented my own idea of cruise climbing. I found I could get down to the edge of the Ruhr, and I'd be way over 20,000 feet. But I took advantage of clouds whenever possible. If there was a very bad cloud, bank of clouds, if there was a front, I'd get stuck inside that one and concentrate on my instrument flying, rather than getting above it or going around it.
But daylight raids were still drawing heavy casualties. Attacks continued throughout the winter of 1939-40. Targets were reached and bombs were dropped, but sometimes more than half of the aircraft did not return. So in April 1940, daylight raids were abandoned and replaced by night operations. Wellingtons now formed the spearhead of the ever-increasing attacks on enemy-occupied Europe. It also helped that Germany's night fighter force was still depending on pilots' eyesight rather than even the most rudimentary form of radar. Night operations brought their own problems for the bombers, though. Results showed that very few of the bombs were hitting their targets. It would be another 2 years before the introduction of radar navigation improved their accuracy.
Bomb doors open. Bomb doors open. Left, left. Steady. Right. Steady. Steady at that.
The Wellington was always popular with the crews because its unique geodetic structure meant that it could sustain an amazing amount of damage and still remain airborne.
But the geodetic structure itself was, of course, an unusual type of structure. It did mean that when the aircraft was hit by enemy fire and it could suffer very extensive damage and still be quite capable of holding itself together and flying. And there are many pictures about of aircraft flying back to base with big lumps missing, canvas burnt away. There's one that I know well that shows the whole of the back end from the rear end of the tailplane, the rear end of the fin. There's no fin or no tailplane or rudder, elevator or rudder on it, and there's no rear gun turret, and yet it got back. Must have been a masterful piece of flying.
Constant updating kept the Wellington in the front line until the end of 1943. One plus was its ability to fulfill any role demanded of it. One of its most important jobs was clearing the magnetic mines that had been laid along Britain's estuaries and coastlines. A huge 48-foot diameter magnetic coil was fixed to the underside of the Wellington. It would then fly low over the mines and they'd blow up as if a ship had passed over them.
It worked by a simple process of a generator in the aeroplane being driven by a Ford V8 and this massive coil hung underneath. That produced a magnetic field which triggered off the bomb not knowing whether it was a ship or whether it was something else. That was a tough job, but what got even tougher was the pressure that came from the First Lord of the Admiralty, one Winston Churchill, who insisted every night on having a set of photographs taken so that he could see how far we got since the night before. We got the thing done, and that was the beginning of it working, and the end of it working was when they cleared the Suez Canal. So that was, in its time, it was probably the most important job that the Wellington ever did.
The versatility of the Wellington in accepting unusual roles was by now well proven. Again, a modification of the Mark I was selected for the installation of a 40mm dorsal gun. It was the heaviest weapon planned to be fitted to an aircraft. But after initial ground trials at Duxford in 1942, the project was abandoned.
Well, another role that the Wellington had to fill was the development of an idea that if you could cruise high enough, like 40,000 feet, for example, over the middle of Berlin, too high to be attacked by any of the fighters that were in service at that time, and you dropped a bomb sort of 2 o'clock, 4 o'clock and 6 o'clock, that might make the citizens of Berlin aware of the fact that there was a war going on outside. We struggled to get to 40,000 feet. There was one version that had Hercules engines, one that had Merlins, and it was a performance.
And of course, crews can't operate at that altitude without being pressurized. So a pressure egg was designed and fitted into the nose, so the geodetics were cut away on the top half of the nose of the aircraft, and this little egg, which contained 3 crew members, settled in there.
It wasn't very popular with the crews because the cabin was so small that it was claustrophobic. I don't believe it was ever used in anger, and there were quite a lot built, so that, if you like, it was a brave try, but it didn't really work.
One eventful test that the Wellington took part in was for the Barnes-Wallis bouncing bomb. Early versions had a steel casing that shattered when it hit the water. Later tests were hugely successful. In 1943, the bombs were used operationally for the one and only time in the famous raid by 617 Squadron on the great German dams in the Ruhr. The versatility of the Wellington seemed to show no bounds. They were flown by every RAF command, apart from Fighter Command. They were used for troop carrying, for maritime reconnaissance, and even as glider tugs. Finally, after the war, a Wellington Mark 10 flight tested the Rolls-Royce Dart engine. That was the famous turboprop that powered the Vickers Viscount and many other aircraft.
When Vickers and Rolls-Royce required a test bed for Dart engines, which were going to be fitted to the prototype Viscount, which was going to fly in 1948, one of the necessary requirements were that the engines were fitted to a completely reliable airframe, and the Wellington was an obvious choice, so that during the flight trials one could forget about any deficiencies in the airframe and concentrate entirely on getting the engines right.
The ubiquitous Wellington earned a distinguished reputation for its multiple roles, and it holds a special place in the hearts of all those who flew it or who worked on it. But it wasn't the end of Wallace's geodetic designs. 2 further aircraft were produced during the war, but they both suffered from problems beyond their control. The first was the Warwick, originally developed in tandem with the Wellington as a heavy twin-engine bomber. But by the time a suitable engine was found, the need for the aircraft had long since disappeared. 845 of them were built, but not one ever reached a bomber squadron. Most of them were transferred to air-sea rescue or transport or meteorological duties. Second was the Windsor, which was a much more advanced aircraft. It was a 4-engined, high-altitude bomber, and it first flew in October 1943. One novel addition to the second prototype was remote-controlled backwards-firing guns on the outboard engine housings. They were controlled by a gunner using automatic gun-laying radar. But development of the Windsor was still underway in 1945 when the war finished, and the entire production order was cancelled. Miraculously, a Wellington Mark 1A built in 1939 and forgotten for 40 years was found lying deep in the waters of Loch Ness in 1985. Wellington has now been lovingly restored by a group of dedicated volunteers at the Brooklands Museum at Weybridge. The Wellington was certainly a great aircraft. More of them were built than any other multi-engine British bomber, proving that a sophisticated design could still be mass-produced. But the Wellington will always be remembered for spearheading Britain's fight back against the might of Nazi Germany. The 1920s were barren years for the British aircraft industry. There wasn't much investment in new aircraft for the RAF, so existing types stayed in service far longer than their useful life. Even the few new aircraft that did arrive were hardly much improved from the aeroplanes that were around during the First World War. Apart from maintaining a severely reduced home defence force, the main job of the RAF in the interwar years was policing the British Empire. But the far-flung outposts of Iraq and India did not offer the kind of opposition that required highly advanced aircraft. Aircraft like the Hawker Hart were more than adequate to cope with tribesmen. It flew at about 200 miles an hour, and it could carry a small bomb load. The pilots at least were convinced of the effectiveness of their aircraft, as well as the value of their role as peacekeepers.
We were very happy flying out there because it was interesting, and you felt you were doing something useful, and we were the only people doing anything useful anywhere in the Air Force. Productive, really useful work for the world at large. So we didn't really worry about whether we were getting better aircraft. We didn't need better aircraft. Better aircraft wouldn't do the job any better.
So there didn't seem much point in spending the depleted Air Force budget on revolutionary aircraft. Same thing applied to heavy bombers. By 1932, old biplane designs like the Handley Page Hayford still formed the backbone of the RAF's heavy bomber force, with their fixed undercarriages and their open cockpits. In 1933, Adolf Hitler, Germany's Nazi leader, walked out of the Geneva Disarmament Conference and declared that he would rebuild his military war machine. High on his list of priorities were modern fast bombers and fighters for the Luftwaffe. It was time for the RAF to expand and modernize. By the mid-30s, the Luftwaffe was starting to get its new aircraft. Soon the world would see such terrifying sights as a dive-bombing Stuka screaming towards the ground, dropping its bomb with pinpoint accuracy. During the Spanish Civil War, German bombers attacked defenseless cities, bombing and slaughtering indiscriminately. The Luftwaffe's Condor Legion gained valuable experience against Spanish cities like Guernica and Barcelona. Any lingering doubts about the potency of the bomber soon disappeared. In 1935, the RAF began to consider replacements for the Hart. They had to look no further than the Bristol Aeroplane Company and its new Type 142. The Type 142 started off as a private order from Lord Rothermere, who then owned the Daily Mail. He wanted the fastest commercial aircraft in Europe. Bristol modified one of their existing designs, and what emerged was a 300-mile-an-hour aircraft. That was 50 miles an hour quicker than the RAF's fastest fighter, the Gloucester Gladiator. The Type 142, called Britain First, flew in 1935. The RAF sat up and took notice straight away. Lord Rothermere promptly gave the prototype to the Air Council. In September that year, the RAF ordered 150 of the new aircraft direct from the drawing board. Frank Barnwell's design team modified the civilian airliner, and it metamorphosed into a light bomber called the Bristol Blenheim. The Blenheim entered squadron service in March 1937. The service aircraft was heavier than the original, and that meant that the top speed was down to about 270 miles an hour. But still, the sleek lines and the powerful Bristol Mercury engines made it an object of desire.
Everything about this aeroplane suddenly hit me as absolutely what I wanted to fly. It was the most, to me, it was the most dashing and charismatic is the word they use now, but in those days we said glamorous looking thing I'd ever seen. It was in daylight camouflage, and I said, "What aeroplane is that?" I said to somebody. "What is it?" They told me, "It's a Blenheim." And from that moment I decided that I was going to fly Blenheims, somehow.
This rare but damaged wartime colour film clearly illustrates the Blenheim Mark I. It had 3 crew members: pilot, navigator bomb aimer, and wireless operator gunner. Unfortunately, the nose of the Blenheim was so small that the navigator could hardly fit in. So when the next major development of the aircraft, the Mark IV, came along, it had an extended nose section to accommodate not just the navigator, but long-range fuel tanks as well. On the 3rd of September 1939, Britain declared war on Germany. The very first sortie of the war was a reconnaissance over the German fleet at Wilhelmshaven by a Blenheim 4 of 139 Squadron. But when the first bombing raids began, it soon became clear that the Blenheim could not defend itself. It was extremely vulnerable to German fighters. On May the 17th, 1940, 12 Blenheims of 82 Squadron took off from Watton in Norfolk to attack German forces in Belgium. The raid ran into heavy flak and fighter defences. 11 Blenheims were shot down. Just 1 got back to Watton, and it was severely damaged. In just 1 raid, a squadron had been decimated.
So on arrival at Watton, of course, we found the ground staff and so on very gloomy, as you can imagine. Morale out there was a bit shattered, to put it mildly. And I mean, it must have been pretty sobering to find that they sent a whole load of aircraft out and none came back. Things were a bit sort of fraught. They flew in new Blenheims for us and so on. And we wondered what in heaven's name was going to happen next.
But soon afterwards, the squadron was reformed. On August the 13th, the crews were woken in the early hours of the morning for a briefing. They were ordered to attack an airfield at Aalborg in Denmark, which was a staging post for Luftwaffe raids on the north of England. This mission was typical of many that had gone before. The squadron, under the command of the recently arrived Wing Commander E.C. de Virac-Laat, took off in 2 flights of 6 aircraft each. The flight to the Danish coast was uneventful. Cloud was a necessity on daylight raids. It was the only defence against the fast German fighters like the Messerschmitt Me-109E. Also, the target was 900 miles from base. With the Blenheim's radius of action of no more than 1,000 miles, it was essential that the aircraft should not have to do any evasive manoeuvres.
One of the things we'd learned about the Blenheim was that it was not really a very good fighting aeroplane. It carried a small bomb load, only 1,000 pounds when all said and done, which is not a tremendous weight of bombs. Carried 1 little pop gun in the back to try and discourage the fighters from coming near it, and it was very vulnerable to being attacked underneath and so on. So that basically we'd learned that the right thing to do was to go in cloud as much as you possibly could, so you could pop in the base of it, so you could pop into it if there's anything aggressive that was coming in your direction, and hide for a bit. And having attacked your target, which were usually coastal targets or that type of thing, the thing was to go right down onto the ground and come home very, very low level so that no fighter could get at you very vulnerable underneath. We went up to about 5,000 or 6,000 feet where we were flying between layers of cloud and had a very pleasant, uneventful trip over the North Sea to Denmark.
The problems began at the Danish coast. 1 aircraft had been forced to turn back, the rest were off course, and to make matters worse, all the cloud cover had disappeared. Under normal circumstances, the mission would have been aborted, but the commander insisted on pressing on.
frankly, my own personal view at the time, I think a lot of other people's was, without any cloud cover and with this amount of land cover, we're not going to do it, we're not going to make an attack. There's no sense in it. However, we did. We ploughed all the way, more or less, from the southeastern end of Denmark up to the northwestern end, which must have signalled to every German within many, many miles the fact that we were coming and making sure that we were going to get a hot welcome.
Around noon, the formation was spotted and German fighters were sent up to intercept. Although the Blenheims had 2 guns, they were shorter range than the enemy cannon, so the German pilots could stay out of range and just pump shells into the Blenheims. The 109s took an arcing track around the Blenheims to attack from the rear. B Flight was quickly shot to pieces until there was none left in the skies. Then the 109s turned their attention to A Flight.
One aircraft more or less blew up and they attacked straight away. I don't know whose it was. But the rest got through to the Aalborg area where the anti-aircraft was good. At 5,000 feet it was bound to be. And inevitably, if we were going to bomb, we had to keep reasonably straight and level. So we were absolute sitting ducks for them. I know certainly at that stage, I can remember looking down over the bomb site and how you could see the gun flashes on the ground. We were as low as that, really. And feeling pretty uncomfortable about it. However, we managed to get our bombs away, and very, very shortly afterwards we lost an engine. So I had a little plan made out in my mind, always being a great believer in having emergencies reasonably covered if possible. And I thought, well, Sweden's not very far away, and that's neutral, and that wouldn't be a bad place to go if the worst comes to us. So I had talked to the pilot about it, and he'd heartily agreed with me that this was a good thought. However, it wasn't to be. We had fighters onto us as soon as we left the target area, and basically we then just were trying to, we were out of the formation, one engine on fire, and under attack. And in a very short time indeed, we lost the other engine. And we were left in no doubt that I think Don Blair did the right thing. He picked a good bit of the fjord to put the aeroplane down in. Unbeknownst to him, of course, was that although it looked nice and smooth and so on, there were rocks just under the surface of the water, because he couldn't possibly see. So no, I didn't actually, I lost consciousness. I can't remember the crash itself. All I can remember was it being very, very hot in the aeroplane. I can remember throwing an arm across my face, and you know, the heat was such that I know I'd still have the scars on my elbow, where it was burnt through to my elbow by the time we got into the water.
One Blenheim did manage to get away from the scene, but it crashed a few miles away. The Me-109s had been in the air for just 30 minutes. In that time, 11 Blenheims were shot down. 20 crewmen died instantly, including Wing Commander De Laat, and a further 13 were captured. Within a period of a few months, 82 Squadron had been decimated for the second time. 3 months earlier, the Air Officer Commanding Bomber Command, Sir Charles Portal, had written to the Air Staff. I am convinced that the proposed use of these Blenheim units is fundamentally unsound, and that if it is persisted in, it is likely to have disastrous consequences on the future of the war in the air. Unfortunately, by this time there were more Blenheims than any other RAF bomber. They had to be kept in constant action, and the subsequent losses to aircraft and crews were horrendous. But the Aalborg raid had finally proved the vulnerability of the Blenheim. It was soon taken off daylight raids, but that was by no means the end of its operational life. Night fighter versions operated in the early days of the Blitz against the German night bombing raids.
I did all the things of pressing the button, and then the silly lighter went into clouds. and I couldn't see him anymore. But I hit his slipstream all the time, and I was waiting for the cloud to pack up, and it didn't. So I pressed the button continuously and waved up and down and sort of gave him a spray, hoping, rather like you do with a 12 bore, if you're hitting at a flock of birds, if you can't see one, well, one might come down.
Later marks of the Blenheim were the first aircraft to be fitted with airborne interception radar. Group Captain John Cat's Eyes Cunningham was amongst the first to fly these Blenheims.
A very nice flying aeroplane. Whether it would be any good as a war machine at that time wasn't at all clear. But as a flying machine, it was straightforward and very pleasant. The Blenheim continued in use in the squadron and was absolutely immensely valuable to lead us into the operation of the Beaufighter.
In 1940, Blenheims were attached to Coastal Command to attack German U-boats and shipping. These attacks were flown at very low level. The crews had almost no room for manoeuvre.
In fact, when you attacked shipping, you flew towards the ships below the decks height of the ship. You pulled up over the mast to toss the bomb into the side of the ship, and it had 11 seconds delay, which enabled you to be about 1,000 yards away when it burst. It was no good dropping it on top of the ship because it would just bounce off, and the fuse didn't go off for another 11 seconds. So you had to fly very low, pull up over the mast, and push down the other side.
Blenheims went on to serve in every theatre of conflict during World War II. They performed many vital tasks for the RAF. Eventually they were replaced by faster, more heavily armed aircraft like the Beaufighter and the Mosquito. In the decades after the war, the Blenheim's achievements and the bravery of their crews all but disappeared from the history books. They were overshadowed by more glamorous aircraft like the Spitfire and the Mosquito. Nearly 2,000 Blenheims had rolled off Bristol's production line, but eventually not one was left in flying condition. But in 1979, former RAF pilot and racing driver Graham Warner put together a young team of volunteers at Duxford Airfield near Cambridge to restore a crashed Blenheim to flying condition.
I discovered the Blenheim abandoned here in a hut at Duxford and thought it was such a shame that it was about to fade from the public view altogether that I determined to see the restoration right the way through to getting it back into the air. So I gathered together the team of volunteers and we started to restore this derelict hulk, which is really all that it was, back into a beautiful flying aeroplane.
In the years that followed, they spent thousands of hours recreating this famous aircraft. The shortage of spares and materials caused them big problems. 7 years after they'd started, the Blenheim was rolled out for the first engine start. The team's years of hard work had paid off. For the first time in more than 40 years, Duxford vibrated to the sound of a Blenheim engine. A few months later, on the 22nd of May 1987, the completed aircraft was towed out of the hangar for a momentous first flight. Pilot John Larkham powered up the engines and the Blenheim began to roll. Just 1 month later, disaster struck. During a display at Denham Airfield, the pilot attempted an unauthorized touch-and-go landing in the Blenheim. He lost control and the aircraft crashed. Miraculously, the 3 crew escaped injury, but the aeroplane was completely destroyed. Amazingly, the team of volunteers voted to restore another Blenheim. Most of the old aircraft parts were beyond repair, but they'd learnt valuable lessons, and this time the process of restoration was much faster. On the 18th of May 1993, another Blenheim took to the skies. The glorious sound of 2 Bristol Mercury engines tore through the quiet of Duxford Aerodrome. This second aircraft was painted in the colours of a Blenheim night fighter. It was named Spirit of Britain First after the original prototype. The 2 restorations had attracted a lot of interest, both from press and from public. The largely forgotten bomber and its courageous wartime crews were now getting the attention they deserved. The efforts of the team had not only restored an aircraft, but a reputation as well. The Blenheim has now become one of the most popular aircraft you can get at your flying display. In 1996, it got a new colour scheme. It now appeared in Coastal Command markings. As a postscript, in September 1995, during building work, the remains of a crashed Blenheim were found at Aalborg Airfield, and a propeller now stands at Watton as a memorial to the crews who died on that turning point raid. But the most fitting tribute is this magnificent flying reminder, still proudly carrying that name, Spirit of Britain First. In July 1921, General Billy Mitchell, a great advocate of air power, proved the value of the bomber by sinking the captured German battleship, the Ostfriesland, off the east coast of the United States. But this feat did not change the opinion of the armed services. As far as they were concerned, the Air Corps was there to support ground forces alone. It was to be another 13 years before a multi-engine bomber was requested. Used to building single-engined aircraft, most of the aircraft industry understood this to mean 2 engines. Only Boeing considered using 4. Model 299, as it was then called, first flew on July the 28th, 1935 at Seattle. It was then flown the 2,100 miles to Wright Field non-stop for evaluation and competitive trials. This flight alone proved that Boeing had developed something special. With an average speed of 232 miles an hour, it was faster than the maximum speed of all of its rivals.
To England, Australia, India, Africa, Alaska they go, making it possible to hit...
The only part of the aircraft's performance that was the same as other aircraft was the bomb load. Boeing had chosen to install 4 engines not to carry greater loads, but to fly further, faster, and higher.
The bomb bay doors open. Bombs away.
The aircraft also carried a vast array of defensive armament, with up to 12 heavy machine guns. Amazed by the world's first all-metal, 4-engined monoplane bomber, a newspaper reporter dubbed it a 15-ton flying fortress, and the name stuck. Although the B-17 went into production, only 13 were ordered for trial purposes. However, as the war in Europe progressed, the USA learned much about aerial combat. They watched the massacre of unescorted RAF daylight bombers. Then they saw how RAF fighters defended British skies against the massed formations of Luftwaffe bombers during the Battle of Britain, and they tuned their strategy accordingly. Boeing had spent many years perfecting the B-17 to be a high-altitude bomber. At a height of 5 miles, the air was thin, and therefore new oxygen systems were fitted. The engines needed superchargers, and everything in the aircraft was tested to make sure it worked in the intense cold. By flying bombing missions at the unheard-of height of 25,000 feet, 15,000 feet higher than either the RAF or the Luftwaffe, they believed that they could avoid anti-aircraft gunfire. In the event of an attack from enemy fighters, they believed that the array of defenses would get them through. The USAAF now believed they had a bomber ready to cope with the stresses of aerial combat.
The invincibility of the bomber had its inceptions back in the days, of course, when Billy Mitchell first bombed the whatever the German ship was out at sea. And the opposition to the bomber in those days was pretty lightly armed too. P-12s and P-26s really were no match for a B-17, none at all. And from this mismatch in our earlier days, I think grew the legend that the B-17 was, and particularly in a sizable formation, would just be practically an invincible force. And the P-40, when it came along, really still didn't terribly challenge this concept. And it wasn't until we really ran up against the next generation, which was the 109 and the Focke-Wulf 190, that we realized that this had introduced a whole new dimension in aerial warfare.
On December the 7th, 1941, the Japanese attacked the US Navy base at Pearl Harbor. Finally, the USA joined the struggle against Germany and Japan. But it'll always be the European theatre of war that the B-17 will be best remembered for. On July the 1st, 1942, though, when the first aircraft arrived in Britain, there was still no hint of the huge role they would play. The Fortresses were undoubtedly the finest aircraft America had ever flown, but the crews were still inexperienced. They'd never flown in anger, and many gunners had yet to fire their guns. Despite this, they were given a very clear directive by the commander of the European Theatre of Operations, Lieutenant General Dwight D. Eisenhower. achieve air superiority over Western France by April the 1st, 1943. Unfortunately, this order was virtually impossible to fulfill. Even as the US build-up began in Britain, aircraft were being diverted to take part in Operation Torch, the US invasion of North Africa. Still, the first raid undertaken by the new 8th Bomber Command was a success. On August the 17th, 1942, 12 B-17s attacked the railway yards at Rouen in northern France. B-17s dropped 37,000 pounds of bombs and returned without loss. It was a good mission to ease the command into the war. There were no daring Luftwaffe fighter pilots, desperate for glory. The bombs were dropped with reasonable accuracy, and the target was near enough for Spitfires to escort them all the way there and back. It wouldn't always be so easy. The first major shock for the 8th came on October the 9th, 1942. 107 bombers attacked steel and locomotive works at Lille. That reached the primary target, 4 were shot down, and only 9 bombs fell within 500 yards of the aiming point. The US Army Air Force, under the command of General Carl Spaatz, was beginning to see that the job was more difficult than many people had thought. Ahead of them was a difficult winter. Bad weather, cancelled missions, and severe losses would severely test the soul of the command.
The cold was the worst thing. The fact that you could touch a piece of metal and your finger would stick to it. 40 degrees below zero, 60 degrees below zero. Sometimes I flew back in the waist. On a few missions I flew in the waist. It was unbelievable back there. With open waist windows a lot of the time. And that air just blowing through there. When I first got over there, you saw so many guys that had frostbite, and it was terrible. But the cold was the worst thing for me.
It soon became obvious that the command had got their tactics wrong, so major changes were instigated in the way missions were flown. Gone were the 3 aircraft bombing formations. Instead, up to 54 aircraft covering a height of 850 feet would bomb simultaneously. To improve accuracy, the best crews were put at the front of each formation. They became known as the lead crews.
Colonel LeMay, when he was command of the 305th Bomb Group, and was confronted with the problems that they were in the early days back in 1942 of placing bombs on the target, or at least within a reasonable distance, found that it was necessary to have all bombs dropped on the signal from the lead aircraft. And he knew that he could take 10 of these better crews, and in practice missions, you wouldn't be able to distinguish between them. But under the conditions of combat, there would be some of those crews that would do better than the others. And this is what they tried to determine when they appointed a lead crew.
The one factor that still caused problems was the lack of escort fighters. Deep into Germany, the B-17s were at the mercy of the German fighters, and despite the firepower of 12 guns in each of 54 aircraft in a formation, losses were unacceptable. The weak link was in the nose, so a chin turret was added. The new B-17G became the most numerous production variant. On August the 17th, the anniversary of the 8th Bomber Command's first mission, two major factories were targeted, the ball bearing factory at Schweinfurt and the Messerschmitt complex at Regensburg. The 4th Bombardment Wing, commanded by General Curtis LeMay, provided 146 B-17s against Regensburg, and General Robert Williams's 1st Bombardment Wing sent 230 of them to Schweinfurt.
There's 4 of them, 1 o'clock high.
They're coming around. Watch.
Sioux Fighter, 6 o'clock up, coming in, diving.
Diving through the 94th.
3 planes, 9 o'clock, coming around. Keep your eye on them, boys. Around the 10.
Watch them, Chuck. Keep your eyes open.
They're breaking at 11. Breaking at 11. I got them. Coming around underneath at 10 o'clock. I see them. 2 at 2 o'clock. Watch them, Scotty. I got sights on them. Check that B-17, Chuck. 3 o'clock. Motor smoking. Fighters 10:30 coming around. Those 10:30 upper or lower?
More than 700 tons of bombs were dropped. The Messerschmitt complex was badly hit, but less damage was inflicted on the ball bearing factory. However, losses were heavy. 60 aircraft were shot down and 600 crewmen lost. 30 aircraft were abandoned in North Africa, where the Regensburg force landed and refueled. 28 that got home were badly damaged. 118 aircraft lost and only 25 German fighters shot down. Morale slumped. The 8th fell back to lick its wounds.
That was the most horrendous day that I spent in the entire war, was the first Schweinfurt show. We started being attacked about mid-channel on our way into Germany, and it was a continuous running fight all the way essentially to the target. And you could look out the window at any spare minute you had almost and see a B-17 spinning out of control, exploding in the air. I never saw anything like it.
But on October the 14th, the B-17s went back to Schweinfurt. In the preceding 10 days, 88 aircraft had been lost, but 300 were still sent to the target. Another 60 were shot down, and that day became known as Black Thursday.
We flew back. We could have flown back just following the fires on the ground from crashed airplanes, both enemy and American. Our 60 B-17s and I don't know how many German fighters. But
we made it back to Biggins Hills, and I believe it was a British transport plane took us back to our base the next day, where we really discovered the scope of the disaster. All the officers, flying officers in my group, left, could eat at one table. I was made a first pilot at that point. 4 of us were actually made first pilots. The next mission, I think I was more afraid of taking off and landing than I was the mission, because I had been on more missions than I had taken off and landed. The 4th mission after that, I was the only one left of the 4 co-pilots that had been made first pilots.
A mission was a long, dangerous time for a B-17. The crew of 10 had to cope with intense cold, flying for hours at 25,000 feet where the air temperature was 40 degrees below. And then there were always the fighters. A damaged aircraft would inevitably straggle behind the rest of the formation. And a single aircraft was a sitting duck for enemy fighters. There was nothing the rest of the formation could do. It always closed up. Safety in numbers until the next attack. The most dangerous time was in the bombing run. No evasive action was allowed. They had to keep straight and level. They waited for the lead crew to signal bombs away, and then they bombed together. Now they turned for home, but there were always more fighters and more flak. Those that fought their way through could see the ground crew anxiously waiting to see how many had returned, and there were always some missing. The aircraft with wounded on board landed first. But the mission was not over. A quick stop for coffee was followed by the debriefing. Did you hit the target? Did you see any of our ships shot down? Were there any parachutes? The grilling went on until the last piece of information was eked out. Only then could the weary crews get some sleep. At that time, a crew's tour of duty was 25 missions. A 4% loss rate meant that there was a slim chance that one crew would survive and return to the United States. But a 4% loss rate did not happen very often. The first and most famous example of a crew to finish their tour was that of the Memphis Belle. By the winter of 1943, it was obvious that the tactics were not working. German production was not being badly affected, and worst of all, the German fighters had control of the air. But in January of 1944, two new arrivals improved the situation. First, the new P-51 Mustang began to equip the fighter squadrons. With 108-gallon drop tanks, they could escort the bombers all the way deep into Germany and back. Second, the invention of a new blind bombing radar system meant that missions could be flown in bad weather. From February the 20th, Big Week as it became known, targeted the Luftwaffe. Every conceivable aircraft factory, assembly plant, storage park and airfield was attacked. Again, losses were high, 226 aircraft lost. But the Luftwaffe was hit hard. 2 months of production was lost. Germany now chose to disperse production, and that made it harder to attack, but at the same time it put extra pressure on the already overloaded German transport system. Never again would German fighters hammer a formation of B-17s from the beginning of a mission to the end. June the 6th, 1944, D-Day. Thousands of tons of high explosives were dropped in support of the invasion. Tanks, gun emplacements, troop concentrations, bridges and rail centres, all were flattened, and barely a German fighter was seen all day. In 3 months, the 8th flew for 78 days out of 92. Oil and industry were still the main strategic targets, but tactical targets were chosen on their merit. By September, despite German aircraft production working at full strength again, fuel supplies had been cut by 75%. German aircraft couldn't fly, and they were destroyed on the ground at a rate of 500 a week. By January 1945, there were very few strategic targets left ahead of the British and American advances into Germany. So it was decided to help the Russians by hitting targets chosen by the Kremlin. The great communication centers of Eastern Germany were selected: Berlin, Dresden, Chemnitz, Leipzig. Target after target was destroyed, as the B-17s flew virtually untouched by the Luftwaffe. By the end of February, Germany was crumbling. On April the 16th, General Karl Spaatz sent out a message to his commanders: "The advances of our ground forces have brought to a close the strategic air war." For 10 years, the great Boeing production lines had turned out an ever-increasing number of B-17s, 12,731 in all. Flown by courageous pilots, navigators, gunners and bombardiers, and worked on by tireless ground crew, the B-17s pounded occupied Europe and Nazi Germany by day, while the RAF hammered them by night. The B-17 was a classic design that proved itself as capable in combat as in testing. It richly deserved to be called Fortress of the Skies. In the early days of the Second World War, it was obvious that Bomber Command's aircraft were woefully inadequate. The single-engined Fairey Battle could only carry a paltry bomb load. The twin-engine Bristol Blenheim and the Handley Page Hampden were too slow and very vulnerable to attack. Only the Vickers Wellington, with a range of 1,500 miles, a payload of 4,500 pounds of bombs and 6 machine guns for defence, was tough enough to survive on daylight raids, where it would meet heavy flak and marauding German fighters. Early losses could not be sustained. In May 1940, daylight raids were abandoned to be replaced by night operations. However, night raids brought their own problems. Crews were not properly trained for night flying, and the lack of suitable navigation aids meant that they seldom hit their targets effectively. In June 1941, the Air Ministry's Butt report concluded that only 1 in 10 aircraft was bombing within 5 miles of their target. In bad weather, that went down to 1 in 15. And with the improvement in German night fighter defences, losses were still mounting. But Bomber Command had to continue the raids. It was the only way that Britain could strike back at Germany and apply some pressure and support of the hard-pressed Russian forces on the Eastern Front. Hopes lay with a new generation of 4-engine heavy bombers and new radar navigation aids. It might be thought strange that the genesis of the RAF's most successful bomber of the war was born out of failure. Avro's original concept was for a twin-engined aircraft designed around the new Rolls-Royce Vulture engine. The Manchester entered service with the RAF at the end of 1940, but it was beset with problems. Unreliable engines, lack of power, and even some airframe defects meant that many of them were lost in crashes rather than on operations. But Roy Chadwick, Avro's chief designer, was convinced that the basic design was sound. He and his team set about reworking the aircraft to accommodate 4 of the tried and trusted Rolls-Royce Merlin engines that were so successfully powering the Spitfires and Hurricanes. The wing was lengthened, and they altered the centre section and tailplane. The first prototype made its maiden flight on January the 9th, 1941, and in subsequent flight trials it performed well above expectations. It was finally named the Lancaster. Had a range of 1,730 miles, a top speed of 275 miles an hour, and at this stage in its development it could carry a phenomenal 12,000 pounds of bombs.
The Lancaster was very, very manoeuvrable. It could be stood on one wingtip and would corkscrew very, very well. It's so manoeuvrable that at least one of the test pilots of AV Row would quite often slow roll a Lancaster after he'd put it through a test flight. I don't think you can get a better recommendation for manoeuvrability than that. I know from personal experience also that it was very, very manoeuvrable, although of course I did not try to do slow rolls with bomb loads on.
Within a year, Lancasters were being delivered to their first squadrons, replacing the twin-engine bombers that had struggled for so long. The Lancaster's first operational sortie in March 1942 coincided with the arrival of Sir Arthur Harris as the new Commander-in-Chief of Bomber Command. His appointment also heralded a new strategy. From that point on, the task was to destroy the will of the German people by the area bombing of their cities.
In entering the war, then the essential, in my view, is you must make sure that you win the war, and that a war is not generally fought by any Queensberry rules. As far as civilian men and women are concerned, I think it is questionable who is the villain of the piece. Is it the people, the civilians, the men and women that make the bombs, the aircraft, the shells, the bullets, etc., that are the villains, or is it the people that use them?
In the first few months of 1942, ever-increasing numbers of Lancasters became available. By May the 30th, Bomber Command was ready for its boldest strike yet. Cologne was to be pounded by 1,000 aircraft, the biggest raid in history, using virtually every bomber in the RAF. 1,500 tons of bombs were dropped. More damage was done in one night than on all the previous sorties on the city. Despite the new bomber, increasing losses were still of major concern. At the end of 1942, it had been calculated that only 13% of aircrew would survive their tour of duty of 50 sorties, and every Lancaster shot down would cost 7 lives.
All the crew get in by the rear door. The forward members have to climb over 2 main spars with all the flying suits and clothing on to get to the front. A crew of 7, you've got a bomb aimer, a pilot, a navigator, a flight engineer, a wireless operator, a mid-upper gunner, and a rear gunner. And I used to fly in the Frazer-Nash 50 mid-upper turret here, which is completely rotating, and because I was right on the top of the aircraft, I was the eyes of the aircraft and was responsible for searching so that we get out of the way of the Ju-88s and Messerschmitt 109s. Behind me is the rear gunner in a Frazer-Nash 20 turret with 4 Browning .303 machine guns. The ammunition for the rear gunner is from large tanks inside the fuselage, which are fed in on a sort of electrical servo feed railway line, bringing the belts up to each gun. I think the 303 air-cooled gun was the finest gun used in the last war. Believe it or not, each gun fires 1,150 rounds of ammunition per minute. So the rear gunner with 4 there has got quite an armory in the back. That on top of the fuselage is a large collar round the base of the turret, and if you look underneath the guns, there are 2 arms with 2 little wheels, and when the turret's rotating, those wheels are going round the top of that collar, and if the guns are rotating depressed and still firing, the arms and the wheels is called a taboo mechanism, which lifts the guns up when you're firing and stops you from shooting down your own fins and rudders and the tips of your props.
In 1941, with only 164 night fighters and a crude detection and communication system, Germany had managed to shoot down 422 British aircraft. A year later, the night fighter force had tripled in size and the control systems had been completely reorganized. The cannon-armed interceptors, mainly the Messerschmitt 110 and the Junkers 88C, were now accurately vectored onto targets by ground controllers. Proficient pilots could shoot down up to 6 Lancasters per night by exploiting the aircraft's main weakness, a lack of protection from the underside.
Although you do see pictures of Lancasters with turrets underneath, there are actually gun turrets underneath. There are very few of these really in actual fact. And the fact of the matter was there was no one in the aircraft who could see directly underneath. So the night fighter pilot's favourite mode of attack really was to attack from underneath in a blind spot. And they had 2 methods. One, first of all, if they spotted a bomber, they would dive out of the way so that the gunners couldn't deflect the guns to get at him. It would pull up underneath and give the bomber a squirt from underneath, usually aiming between the engines where they knew the fuel tanks were. And later on, they even fixed upward firing cannon, which they called the Schreiger music or slanting music. And these consisted of a pair of cannons pointing upward, almost vertically upwards. And all they had to do then really was to find an aircraft, get underneath it. And of course they were flying along at the same speed underneath it, it was almost impossible to miss. And many, many aircraft went down to this sort of attack without knowing actually what happened to them. They would obviously aim for the fuel tanks and not for the bomb bay, because if the bombs went off, well, it would probably take the fighter with it as well. So they were a bit reluctant to do that. This was the great problem. But of course, that was liable to happen at any time. Really, the gunners, and the usual way we operated as a crew, and I suppose others did, the pilot would take a quarter of the sky from the front out to his wingtip. The engineer would be keep looking out this side round to the other wingtip, and the 2 gunners who were at the mid-upper and rear positions would also take a quarter of the sky. So it was rather like a ship, and they would be keeping a damn good lookout. And I think it is a fact that the guns on the Lancaster were not really used very much. The most important job was for the gunners to keep a jolly good lookout and to tell the pilot if they saw anything. But if you saw an enemy aircraft and it didn't think it had seen you, you wouldn't fire at it. You would tell the pilot and you would try to get away, because if you fired your guns, it gave your position away and probably you'd have more fighters come down onto you. So really, firing the guns was a last resort if you thought you were going to be attacked.
It wasn't until July 1943 that an effective solution was found. Bombers dropped bundles of foil strips, known as window, to confuse the German radar.
they created lots of spots and blips on the radar screens, and it made it almost impossible to pick out the aircraft or separate them from the tinsel strips. And this was something which, as soon as you approached the enemy territory, you'd sit on the step down in the nose there, and there was a little chute in the side of the nose, and you could, under these bundles of tinsel would probably be this deep, and we'd push this window out at about 2 bundles a minute for perhaps a couple of hours on end. And when you arrived at the target, the bomb aimer would have come down, so it got a bit congested. He would be in the nose as well, and he used to start up to about 5 bundles a minute with this window.
For the beleaguered men of Bomber Command, any success was a major morale booster. One of the highest profile raids of the war was flown on the 17th of May 1943. 19 Lancasters were specially adapted to carry the revolutionary Barnes-Wallis invention, the bouncing bomb, which was designed to breach German dams. Wallis predicted that these bombs could destroy 3 dams in Germany and that the resultant flooding would cripple German industry in the Ruhr Valley. Flying at ultra-low level, Lancasters of the specially formed 617 Squadron breached the Möhne and Eder dams. Though the results did not show the level of damage that had been hoped for, the raid epitomised the spirit of Britain's resolve, and the versatility of the Lancaster had been proved beyond doubt. The Lancaster's huge bomb bay meant that an assortment of weapons could be carried. One of the most devastating loads was a mixture of 1 8,000-pounder and 6 500-pound general-purpose bombs. And in the spring and summer of 1943, 60,000 tons of bombs were dropped on Germany's industrial heartland. In July 1943, Bomber Command turned its attention to Hamburg. During one 10-night period, 4 huge raids were mounted using more than 300 Lancasters each time. The result was a firestorm that engulfed huge areas of the city. Buoyed by this success, Harris planned a maximum effort against the great prize, the German capital. Churchill himself approved the plan, and the Battle of Berlin began. Berlin was different from any other Bomber Command target. It was much bigger, and therefore attacks were much more difficult to concentrate. Winter weather and other commitments meant that Harris had to schedule raids over a long period, allowing Berlin time to recover in between. By the spring of 1944, Berlin had not been smashed as Harris had hoped. The spirit of the German people had not wilted, and more than 500 RAF bombers had been lost during the raids.
It often was very, very boring. There were long periods on, say, an 8-hour trip when nothing much was happening at all, but you couldn't really relax because you never knew about the night fighters. They'd steal up behind you in the early days and attack from the rear, and if the gunners were awake, you had a good chance of spotting them, especially the rear gunner, and you could probably then take some evasive action. The standard evasive action in 5 Group, which was the group to the south of Lincolnshire, was the corkscrew. This was essentially a sudden diving turn and then rolling at the bottom and going in the opposite direction and then climbing again, twisting from one side to the other and repeating the whole process.
We were attacked by a Ju-88 over the sea, and the gunner spotted him, called out for the pilot to go to, I think it was corkscrew to port, and as the wings tilted, he fired at us, and he took about 2 feet off the top of the rudder and a chunk off the end of the wing, and that was the most damage we suffered. Fortunately, the rudder still worked and the aileron still worked, so we were able to come home, and he only made 1 run at us. He obviously thought we'd spotted him and he was not going to chance his arm anymore. But that's a typical kind of attack.
To enable the bombs to be dropped as accurately as possible, it was necessary to fly straight and level. And whilst we were in straight and level position, of course, you were much more vulnerable to fighter attacks. The navigator would indicate that you were X minutes, 2, 3, 4, 5 minutes from the actual target, and you would then get on to straight and level, and as you approach target, open the bomb doors so that the bomb aimer could release the bombs, and from then on you were just a bomb aimer giving instructions to the pilot to make sure that you came up on a correct bombing run until he had the target in his sights and he pressed the bomb release to release the bombs. Being coned in the searchlight, I suppose, was one of the worst things that could happen to you, because you felt as if you were the only person on the raid, that every gun in the area and every fighter was being concentrated on you, and of course it was like daylight in the aircraft, and it was very difficult that if you did take any very evasive manoeuvre as you turned the aircraft onto its side, then of course you got the full blast of searchlight into your face, and therefore you were partially blinded. One of the tricks that I understand that some people employed was that if they were coned in searchlights and they were not managing to get out, if they saw another aircraft above them, then if they flew directly underneath that aircraft, so that at one time the searchlights had 2 aircraft, if they continued their turn, there was a 50-50 chance that the aircraft which remained in the searchlight was the one they'd flown underneath and not themselves.
June the 6th, 1944 marked the beginning of the long-awaited counter-offensive in Western Europe. In support of the ground forces, Bomber Command unleashed a ferocious aerial assault on German troop concentrations, arms dumps and communication links. Because they could be delivered by day, these raids were very accurate. That was possible because the targets were close and fighter escorts were available. Particularly successful was the attack on the E-boat base at Le Havre. Carrying Barnes-Wallis's latest invention, the 12,000-pound Tallboy bomb, the most up-to-date Lancaster 3s of 617 Squadron destroyed the hardened shelters and effectively negated the E-boat menace. Some months later, the success was repeated when the pride of the German Navy was sunk in Tromsø Fjord, Norway. A combined force from numbers 9 and 617 Squadrons found the battleship Tirpitz and scored a direct hit with the Tallboy. But the ultimate in conventional high-explosive bombs came in early 1945. The most potent of Wallis's inventions was the massive 22,000-pound Grand Slam bomb. It was too big even for the Lancaster's capacious bomb bay, so it was slung underneath the fuselage and dropped by an electrical release mechanism. When the bomb hit, it would penetrate 30 feet into the earth before it exploded. And a massive crater would be formed. Anything above would fall into the hole.
And here is the result. Although not a direct hit, many yards of the viaduct have been destroyed. The Nazi world is in ruins.
But the vast majority of Lancasters were continuing with the area bombing of German cities. On February the 13th, 1945, one of the most controversial raids of the war took place. The beautiful city of Dresden appeared to hold no strategic significance except as a junction for German troops either travelling to the Western Front or retreating from the east. But it was on the list of targets, and 769 Lancasters pounded it, dropping more than 2,500 tons of bombs. Tens of thousands of civilians lost their lives, and much of the city was devastated by a firestorm. And the German night fighters were in such a shattered state by this point that only 6 Lancasters were shot down. Just 11 weeks after the Dresden raid, Germany surrendered. Discussion over the effectiveness of the strategic bombing campaign will continue for many years to come. But of one thing there is no doubt. the systematic destruction of Germany's industrial heartland forced the dispersal of arms manufacture. When the arms were moved, they were severely hampered by the destruction of road and rail links. Compounding the chaos, an offensive against Hitler's synthetic oil plants caused the Luftwaffe literally to run out of fuel. In the forefront of the tens of thousands of sorties flown against Germany was always the Lancaster. The 59 squadrons of Lancasters dropped more than 600,000 tons of high explosives and a staggering 51 million incendiaries. These versatile aircraft, carrying a wide variety of bomb loads and flown by the exceptionally brave men of Bomber Command, plied their routes night after night to the flak and fighter-filled skies of Germany, delivering the Allied message of impending victory. But the Lancaster's wartime swan song was not a bombing. Instead, Operation Manna dropped stores and food to the starving citizens of Holland.
Holland was starving. There were no cats left to kill. Even the dustbins were empty. But in a few days, Bomber Command dropped over 2,000 tons of food, and the immediate crisis was past.
When I fly around these days, especially in Lincolnshire, it strikes me that not all that many things have changed since the aircraft flew around in the war. And obviously, when we fly around, we're the only Lanc there, but you're trying to think of the idea of, with all the airfields around this area in Lincolnshire, all the other Lancs flying around as well, and the fact that you must have nearly always be able to see some other Lancs somewhere in the sky. It's one thing we don't do, but of course on the ground, many of the ground features are just the same. Some of the old airfields are still there, you still see them. And often we fly past Lincoln Cathedral, which is one of the landmarks, which was obviously very poignant for guys in the war. And the coastline hasn't changed much, the wash is still the same, much the same. And people often ask me if it does feel the same as if flying in the war. And of course, to me, the situation is very different. I've got no fear of being shot at, I've got no fear of the weather because we never fly in bad conditions. And the only sort of slight nagging doubt in the back of my mind is trying to carry off a presentable landing at the arrival point.
The Lancaster, in my view, was the best of the four-engined aircraft. It was a bomber designed to do a specific job, which it did extremely well, and helped in no small measure in the ultimate victory of the Allies.